Okay, so these problems that you guys missed on your quiz, or similar problems, number 6. If you haven't finished that one yet, then you probably do not know the quick way to do that. Okay, so quick review, identify the asymptotes. First, you could change it to the form of g of x is equal to a over x minus h plus k by using polynomial long division. You could go that route. I personally would find the x asymptote by looking at the denominator. You could do that either way. That's not going to change no matter what form you're in. So that would be, what makes that 0? 1. Now remember what we talked about in terms of the y asymptote, or your vertical asymptote. Okay, your vertical asymptote is the coefficient of the x values, as long as the powers are the same, which they are. Okay, so right now the coefficients of this is 2 over 1, or 2. That would be the same thing as if you changed it to this format. That 2 would end up right here. So if you're like, I don't quite get that, first I'd hope that you eventually go back and look over that lesson. But if you say, I really need to put it in that format, then you got to think 2x minus 4 and x minus 1. Think to yourself, x times what is that? That's 2. 2 times x, 2x minus 2. Thank you. Okay, and then you get negative 2. Okay, now, did we mess up somewhere there? No? 2x, good. Negative 2. Okay, and so that would give you negative 2 over x minus 1. So you get g of x I have that. I shouldn't have put 2 negatives up there. Sorry about that. Okay, all plus 2. And so there's our k term. Horizontal asymptote is 2. So you got to think to yourself, like if you're like thinking about it horizontally, maybe draw the line. That line for a horizontal asymptote would cross over the y-axis. All right. Any other questions there? Not your dog. All right. Number 8. Is the graph of a branch of a rational function? I didn't look at this before I printed. I should have expanded this text box out. That's supposed to be a rational function, so if you want to make it, okay, a rational function, is this graph the graph of a branch of a rational function, or the graph of an exponential function? Explain. By the way, you guys, these numbers are the specific quiz problem numbers as well. So like number 8, if you missed that one, it's a similar question to this. Okay? They actually give you 2 pictures and say which one is a rational and which one is a exponential. I want to know, is this exponential or rational? How many of you think you know? Okay, right now, tell your neighbor what you think it is. Okay, here we go. Own your decision. How many say rational? Exponential. How many have no clue? Okay, this is exponential. Why is it exponential? Matt?
Well, you can look at your points and they have 0, 1, which is a common exponential value, like in exponential equations that aren't shifted.
Okay.
Have a point 0, 1 on the graph. And then as you go up, if you were to take it into a table, you see that you're getting a square each time.
Good, and I would probably even just go that route. If I'm making a table out of this, if I'm just looking at all my points, what you should know about exponential. You don't even have to, if they tell you one's rational and one's exponential, really you look for the exponential one. Because what you should know is, like, if you look at your x values, as x is increasing by 1, which we are here, actually I guess if it's increasing by a constant amount, which we are this time by 1, your y values should be going up by a common ratio. That's 1/9, 1/3, 1, 3, 9. What are we doing each time? Multiplying by 3. And so since you're multiplying by 3, this is exponential. Okay? All right. Yes? In terms of a rational one, first you would have to, well, if you're just looking at a table, like if you put it in table form, remember rational, as long as there aren't any shifts, it'd be x times y is a constant. Now, I don't recall in that problem if there were shifts to it. So, I can't tell you for sure if x times y was a constant in the actual problem. But what I do know is if you're comparing a rational and an exponential, and you have to choose one or the other, identify the exponential. That's the easiest one to identify. Okay. All right. Number 9. The time t. Yes. Is it a question about this one?
No.
I can't have you ooh-oohing because it distracts the class.
It was about 9.
Okay, let's do number 9. Okay, the time t in hours it takes the group of workers to build a cabin varies inversely with the number of workers. The time it takes 12 workers, 15 hours. So if it varies inversely, remember that means x times y will give you a constant value, which we called a. Okay, and our inverse variation, for those of you who recall, we usually write that in the form of y equals a over x. So to find a, I can take the two things that are varying inversely, 12 and 15, and find a. 12 by 15 is 180. So a equals 180. Now I will tell you that some of the problems that some of you, or the problem that some of the students had on this one, wasn't necessarily that they couldn't figure this part out. It's that they put that answer, or an answer like that. Where in context of the problem, that is incorrect. Yeah. T and N, right? So the time it takes varies inversely with the number of workers. So our time depends on the number of workers. So we would have N and we'd have T. So our Y value is actually our T and our X value is actually our N. Well, technically it doesn't matter in this. The reality is, though, the way you're writing it and the way you're reading it, the time is going to depend upon the workers, and y is your dependent value, so time would be dependent. When you're figuring out this, though, it doesn't matter because you're multiplying n by t. I think on the quiz, they actually told you t equals what? I think they asked it like that. Okay, and then you put, a lot of students I saw put 180 over x, which if you talk to me about that, I ended up giving credit on that. Okay, however, you should use in context of the problem. You should put the n. That's why you missed it, if that's what you did. Okay, write the inverse variation. There it is, relating n and t. Sorry. And then letter B, make a table. If we're going to make the table, that would be our n. That would be our t. For the number of workers to be 6, 20, 24, and 30. Note n times t, since it's inverse variation, n times t would be constant. We know n times t is 180. So 6 times 30 is 180. 20 times 90 is 180. 24 times, I believe, 9, thank you. I believe it's 7.5 here. And then 6 here. Okay. Questions there? How many are seeing the problems they made? The mistakes they made. That's our goal. Any questions? Yeah, Jordan.
I think I'm just forgetting. How come we're multiplying or dividing 110 by 180?
It's because it's inverse variation says x times y will give you a constant term every time. In this case, x times y is 180. Okay. All right, number 10. Company purchases a copier for $2,000. The materials for each order is $15. Estimate how many orders must be printed for the average to fall to 65. Okay. So remember, if we're dealing with the average, we're taking, in this case, we're going to take the total cost and divide it by the number of printed, the number of orders printed. Okay, and that's going to give us our average. Okay, so our total cost is $2,000 plus 15 per order. If we call the order like C, or maybe not C, maybe we say P for printed. Okay, and then orders printed, we divide that by P. That's the number of orders printed. That's going to give us an average cost of $65. Okay, so first you have to recognize that a cost is that linear equation, 2,000 plus 15p. P stands for the number of orders we printed, and 65 is what we want our average to fall to. So we cross multiply. It gives me 65p, and that's equal to 2,000 plus 15p. All right, we go through and we actually end up solving that out. You get P would equal 40. Okay. So we need to make 40, or have to have 40 orders printed. All right. What happens to average as more orders are printed? The average approaches, Walsh? Good. Average approaches 15. All right. Remember, that's when P increases to a huge number. Yeah? The 15.
Yeah, is that like always going to be the number that it approaches? Because I like plugged it into my graph and it came up to like 0. So I was like,
it should. Yes. So Roy, the answer is yes. It should be that number. Okay, and really what you're looking at, you know that 2,000. So if you're trying to find what it's approaching, you know that 2,000 plus 15p over p is equal to that average cost, which we'll call C. So really that's 2,000 over p plus 15 over p if you break this piece up. 15p over p, excuse me. Okay? And so those two pieces would cancel. And so you would end up with 2,000 over p plus 15 equals cost. Okay, well, if you think of that in terms of a rational equation in a over x plus k, here's your k value. That's your asymptote. Okay. So that's your horizontal asymptote that you're approaching. And that'll always happen like that, yes. Okay.